kind of interesting. So my background has always been in software engineering. I started coding in elementary school and then went to college for it. But my wife is a neuroscientist, and so she'd been doing Parkinson's research. And we got to talking about how there was a lot of human data that was underutilized, but the biologists didn't know how to query it. And there was this great NVIDIA GPU compute power coming online, but the computational people didn't know anything about biology to apply it. And so we started prototyping at home how we could put those skill sets together. And that led to computational biology that led to a pipeline, kind of organically grew into it. Yeah, we came into this to try to stop the progression of Parkinson's disease. Up until now, all of the treatments just masked the symptoms, but we believed that we could look at human data and find a new drug target that would actually stop the neurodegeneration. And that led us to dysfunctional mitochondria, the clearance of damaged mitochondria as the key mechanism. So we now have small molecules that can boost this, which are going into the clinic next year. This we expect will stop progression of Parkinson's, but maybe more excitingly, this mechanism actually slows down aging. And so it may even extend lifespan or protect in other age-related diseases. This will be the first molecule that can selectively clear damaged mitochondria without clearing the healthy mitochondria and without actually damaging mitochondria. So this process of mitochondrial recycling, called mitophagy, has been known to be important for a while, but there are a few supplements or other drugs that do boost this process, but they almost entirely do it by actually causing some damage. And then you have to be really careful about not giving too much and causing too much damage, and about not clearing the healthy mitochondria, because that can be toxic too. So this new mechanism that we identified allows us to selectively clear the damaged mitochondria without having to induce damage to do it. One of the key drivers has been the Michael J. Fox Foundation. They are so great at pushing collaborations and at backing early, kind of moonshot ideas. We had this kind of wild idea that we could simulate cells in the computer and have virtual human cells that would be more predictive than animal cells. So we bootstrapped our prototypes to our first funding from the grants from the Fox Foundation. And that backing and collaboration with other researchers to validate things in the lab really gave us the momentum to just keep working on that project. And it's really comforting now to see these ideas that started as like, can we even do a simulation, to yes, the simulation holds up in the lab, and yes, we can make molecules for it. And now next year, these molecules are going into the clinic. The mechanisms of aging are super exciting, and specifically the intersection of what changes as people get older and mechanisms of disease. And that's where Parkinson's is this great model system where aging is the biggest risk factor for the disease, but you also have about a dozen human mutations that are causative for the disease. And so you can kind of look at the overlap of those mechanisms and find something that will stop Parkinson's and slow aging. So I think there are a lot of other opportunities like this where we can look at lipid homeostasis and Alzheimer's disease, or diabetes and some of the inflammation. Like there are all these points of overlap that we know get worse as you age, but also kind of are key hallmarks of a disease. And with AI, our ability to now unravel the biology and turn new insights into new drugs, like drugging the undrugged space is super, like there's a huge potential here where we can start to really program biology and make small tweaks to adjust it back into homeostasis and health. And I think that's just going to be running like crazy over the next decade. We've selected our development candidate molecule that is on a track toward human clinical trials. We should be IND ready in the first half of 2026. We're starting to talk to a lot of pharmas around partnering, particularly in the Parkinson's disease space. The big pharmas are eager to partner early on programs as opposed to waiting for that human proof of concept later on. And so we're in a lot of those conversations. We also, earlier this year, partnered one of our molecules that was optimized for topical use for anti-aging skincare, which was kind of surprising. Not really on our radar until we connected with a company, Beiersdorf, who you may know some of their sub-brands like Nivea and Eucerin that are pretty popular. So they've been excited about mitochondria for a long time and see potential for our molecules to actually slow aging, increase collagen production, reduce inflammation, and promote more youthful skin. So they've actually licensed one of our molecules that is now working through the development process and could be in skincare products actually much faster than the long FDA approval process for Parkinson's. One of the key things that I'm excited about is the potential beyond Parkinson's disease. A lot of these approaches that we've had with using AI to aggregate a lot of complex information and now having an efficient drug discovery and optimization engine, I think there is a lot of potential at that intersection of aging and disease. So while the next 6 months is really exciting to get into the clinic, I think that's just the tip of the iceberg, and there are a lot of really exciting projects that are queued up behind that.